The project that I'm going to be talking to you about today is our water purification and space conditioning effort. And it's a way to extend our expertise in absorption heat pumps to produce multiple useful outputs with the same system architecture. Water is a big problem because we have increasing global water use, but we have finite available freshwater supplies. And that means that we need to explore some novel water production technologies. The challenge there, though, is that if you have a high energy water production technology, you end up needing water to produce the energy to produce the water, and so you pay a penalty there. Our idea is that we can take an absorption heat pump and we can modify the system architecture by breaking the loop between the condenser and the evaporator. What this then allows us to do is we put gray water or another impure water source into our evaporator, and as that water is evaporated, absorbed, desorbed, and finally condensed, it undergoes what's effectively a double distillation, allowing us to start with an impure source and finish with a distilled quality water. We've done some thermodynamic modeling on this cycle, and we're using three figures of merit to assess that. The first is the coefficient of performance from heat pumps. The second is the performance ratio from desalination, and we combine those to form an energy ratio, which gives us the total useful output of the cycle divided by the power input. What we see for about a dozen different absorbents that we've used to simulate the cycle is that we almost double the energy ratio by modifying the cycle so that it produces pure water in addition to cooling. Right now, we're in the process of using this test stand right here to test and really prove the concept that we can do water purification and space conditioning with an absorption heat pump. The heat exchanger you see in the front is our prototype evaporator and condenser. Evaporator when operating in a low pressure mode, condenser when operating in a high pressure mode. The heat exchanger in the back is a prototype absorber and desorber. Again, absorber in the low pressure mode, desorber in the high pressure mode. And by running sequential experiments where we first run the low pressure mode and have evaporation and absorption, and then the high pressure mode where we have desorption and condensation, we can prove that we can in fact get water purification and space conditioning out of the same cycle, which when applied to residential conditions can give us over 50% decrease in indoor water use.